Hi, welcome to 1-7 Simplifying Expressions. The target for today is I can use the commutative, associative, and distributive properties and combine like terms. Please add that. We're going to be looking at some definitions with properties. So I've filled in some blanks for you. The commutative property is where you can add numbers in any order and multiply numbers in any order. So please insert the word add numbers in any order and multiply numbers in any order. And let's think about two numbers. So let's say I have 3 plus 7. That gets me a sum of 10. Well, if I have 7 plus 3, I get the same sum of 10. And I could also multiply in any order. 3 times 7 is 21. And 7 times 3 is 21. So again, the commutative property says order doesn't matter with addition and multiplication. In general, the rule looks like A plus B, meaning adding two different numbers, is also equal to B plus A. And A times B is also equal to B times A. That's your commutative property, where you deal with the order with addition and multiplication. The associative property is when only adding or multiplying, you can group any of the numbers together. So if I'm going to take 2 plus 3 plus 4, I can group, and I'll use parentheses to group, the 2 plus 3 and get 5 plus 9. 5 plus 9 is 14. Just kidding. 5 plus 9. Why did I do 5 plus 9? 5 plus 4 is 9. Well, I can also do that problem again. 2 plus 3 plus 4. But this time, I'm going to group the 3 plus 4 together first and get 2 plus 12. Oh my goodness. 7. And I also get 9. So this works also for multiplication. All right, so only when adding and multiplying, you can group numbers. Sometimes we do that to get friendly numbers, which we can then exercise that mental math skill. So we can look at it as A plus B plus C. And again, we can group A plus B is also equal to A plus B plus C, where we group B plus C. And same thing with multiplication. A times B times C, but I'm going to group A and B together, equals A times B times C, and I group B times C together. Again, associative property works with grouping numbers with addition and multiplication. All right, last one, distributive property. So we can multiply a number by a sum or multiply each number in the sum and then add. And the result is the same. So a couple different things. If we see something like 3 times 2 plus 1, what we can do is it says you can multiply a number, meaning 3, by a sum, meaning we'll add 2 plus 1, or we could multiply each number in the sum and then add. So let's do it this way. Order of operations says that I can combine anything in parentheses. So I'm now going to have 3 times 3. 3 times 3 is 9. But let's say I can do this problem, but I'll first multiply each number in the sum. 3 times 2 is 6. 3 times a positive 1 is 3, and I get 9. So I recommend using order of operations first, but there will be many times when we're given a problem like 2 times x plus 1, where we cannot combine the x plus 1 because they're not like terms. So here we would have to distribute. Our trick is called the Santa hat. Because if I look, when I'm distributing a number, it looks like a Santa hat. What the rule looks like or what the rule states is that it's A times B plus C. Again, we can distribute and have AB plus AC. All right, so let's go ahead and simplify some expressions and state which property is used to make our life a little easier. All right, so if I see 5 1/3 plus 4 plus 1 2/3. Well, if I can change the order and get this term closer to that side, then I can add my fractions. So I'm going to have 5 1/3 plus 1 2/3 plus 4. I just changed the order, so I used the commutative property. Now, I can go ahead and add these two. I know that 1/3 and 2/3 makes 1. So really, I can say 5 plus 1 plus 1 plus 4. And if I add those, I should have 11. So I use the commutative property to get these numbers next to one another. Well, let's take a look at number 2. I can group some numbers together, so I can maybe use mental math. Let's see. I'm going to first do 1/2 times 8, because I can do half of 8 in my head. So I'm going to group 1/2 times 8 using the associative property. Half of 8 is 4, times 7 gets me 28. Number 3, I simply see 8 and then 33 inside parentheses. I know that's 8 times 33, and I should get 264. It's using multiplication, but we did draw that rainbow, or that Santa, partial Santa hat, distributive property. And number 4, this is where we have a number in front, and we see, again, an algebraic expression inside parentheses. 7 times x, so 7 times x is 7x. 7 times 2 is positive 14. And we cannot do anything further. We'll learn about that here in a minute. But this is our final answer. We once again use the distributive property. All right, moving on to the next page, we have some more words. And I have some things filled out. I'll use a highlighter as we go over them. What are terms in an algebraic expression? We talk about the word terms. Terms are parts of an expression separated by plus or minus sign. Okay, so copy that down. And when I look at this expression, how many terms? Well, I have 4x, 5y, and I did a 2 pencil mark trick and have -3. So 4x, 5y, -3, we have 3 terms. And what are they? I just listed them out. 4x, 5y, and -3. Like terms. When we talk about like terms have the same variable and the same exponent. Take a minute, copy that down. Right here, and I'll highlight these in pink, these are all examples of like terms. 5x plus -2x. They both have x to the first power. These are all like pairs of like terms. So 3x plus 2x, 4 and -5, x plus 4x, and so on. Those are all like terms. Examples of non-like terms. Here's an example here, 4 plus 6x. Well, this term has an x, this one doesn't. They're not the same. They don't have the same variable to the same exponent. 2x plus 3. How about 2x plus 3x squared? Remember, we said same variable to the same exponent. Only the second term has a squared. And then the final word is coefficient. And a coefficient is a number in front of a variable. So a number in front of a variable. Let's see what that looks like. And a few examples here. So I have negative 6x squared times y. The coefficient is the number in front of the variable. In this case, it's negative 6. For x, well, there really is a 1 in front of it. I'd encourage you to write that 1. The coefficient is 1. And for the last one, negative x, well, really this means negative 1x. So the coefficient is negative 1. And something to always remember is look at the sign to the left. So look at the sign to the left. We'll practice that down below. All right, let's take a look at number 5. Okay, number 5. We have quite a few m and n's. We have 3m squared times n minus 2n plus 6n plus 3mn minus 6m squared. First and foremost, I'm going to do some 2 pencil mark tricks because I want to have everything as addition problems, even if we're adding the opposite. All right, so I'm going to be looking for any like terms that are like terms that I can get next to one another using the commutative property. So I see that I have negative 2n and 6n. Okay, well, let's write those together. Negative 2n plus 6n. If I look at any other terms, I don't have any more like terms. I have m squared times n, m times n, and then m squared. So I'm just going to carry everything else down, including the sign to the left. And now I use the commutative property to reorder. So I have like terms next to one another. These are the only 2 terms that I can combine. So negative 2n plus 6n is 4n. And I can go ahead and copy everything else down. And that is the expression simplified. Let's go ahead over to look at number 6. I have 14x plus 4 times the quantity 2 plus x. Well, when I have parentheses, I'm going to look, is there anything I can combine there? Well, hopefully you said no, because it's 2 plus x. They're not like terms. So I'm going to use the distributive property. 4 times 2 is 8. 4 times x is 4x. And I'll carry down the 14x. So I use the distributive property. And now I'm going to reorder so I have like terms next to one another. 14x and 4x can be written next to one another because they're like terms. They have the same variable to the same exponent. Now I can combine them. 14x and 4x make 18x. I'm just adding the coefficients. And 18x plus 8 is my final answer. I cannot combine them because they're not like terms. Last but not least, number 7. I'm going to do a 2 pencil mark trick here inside the set of parentheses. and I'm gonna look, can I combine anything? Well, I can't take anything out of the parentheses, so I'm gonna look inside. I cannot combine them, which means I need to do the distributive property first. So 5 times p is 5p, and this is a negative 1p squared. So 5 times negative 1p squared, I multiply 5 and negative 1, and I get negative 5p squared. I'm going to carry everything else down. And now I'm going to look. Hopefully you see that you can reorder using the commutative property to get like terms next to one another. I'll get my p squareds together. So 7p squared plus negative 5p squared. And then plus 4p plus 5p. Go ahead, try to simplify, and let's compare final answers. All right, do we have 2p squared plus 9p? You should. All right, so this was section 1.7, simplifying expressions. Thanks for watching.